Okay, so today we're going to repeat that same number sense standard, knowing that rational numbers are not rational. They're called, or that are not rational, called irrational. And we're going to use, not necessarily our cube roots, but we're going to use some information that we know about rational and irrational numbers to learn more about them. Okay, so these are number lines, right? You're very familiar with them. We use them. And we have one up on the wall in the room. And what they do is they provide a place for us to put our numbers. Okay, so if we head in this direction, we have positive numbers. All those numbers are positive. If we head in this direction, we're looking at negative numbers. But these numbers are all rational. Why are they rational? Because they have a place on this number line. Now, if I was to blow up my number line between here and here, this is what it would look like. And if you notice, on this number line, we have a bunch of fractions. And the number of fractions are limitless. But as long as I can write this number as a fraction, then these are all also rational numbers. Even my negative numbers are rational numbers. So let's go over the definition of rational numbers. Before I do that, make sure you're pausing your screen and copying down both of these number lines. Include fractions in there. Okay, so we're going to go on. Next screen. So here's our definition of rational numbers. A rational number is any number that can be represented by a ratio. And if you look at the word rational, the word ratio is right in there. And from 7th grade math, we learned that a ratio can also be written as a fraction. 7 to 2. Or change in x over change in y. Okay, so any number that you can write as a fraction or as a ratio is a rational number. So if we look at some examples down here, see here is written in the form n over d. Now n and b have to be non-zero numbers, or d has to be 0, because you can't say 7 divided by 0 is not possible. This is undefined, if you remember that. Since 7 divided by 0 is undefined, it is not a rational number. Okay, not rational. But here we have some examples. 16 is a whole number. I can write 16 as 16 over 1, right? I can also write it as 16 over 100. Okay? Let's, oops, I want to erase this. Another example we have here is 1/2. This is 1 over 2, right? It can also be written as 0.5, right? This is 1/2. Fraction or decimal, these are both rational numbers. 3.56 is also a rational number. We can say 3 and 56 over 100, right? This is my mixed number. This is a rational number. It can be written as a fraction. I can also turn this into an improper fraction and say 356 over 100. And now it's still a ratio, correct? It's still 356 to 100. Negative numbers, as we saw in our number line, are rational numbers. Now this is 1.3333, and looks like 3 is a repeating decimal. So we can actually write that as 1.3 and put a bar over that. But as long as it repeats, I can write this as a fraction or a ratio. This becomes 13, right? over 100. It's a fraction. It's a ratio. Part to whole. So repeating decimals, I'm going to write this down. Repeating decimals are rational numbers. Negative numbers are rational numbers. This is a whole number or a counting number, natural number, are rational numbers. This is a fraction. It can be written up. It's a rational number. Here we have a decimal. It is a rational number. Here I have a negative fraction. It is a whole number. I'm sorry, it is a rational number. So here we have at least 6 different types of rational numbers. The difference between a rational and irrational number is, so make sure you're copying this down. Remember, we're on page 14 of your table of contents, so these notes should be labeled page 14 on the bottom corner. Copy this down. Go ahead and push pause. Make sure you got it written down. And then when you're done, come back, push play, and we will continue. All right, we're going to continue. Here I have a definition of irrational numbers. Irrational numbers cannot be represented as a simple fraction. So pi, if we know anything about pi, it keeps going, right? It's 3.1415926, and it just continues. We have not found the end of this decimal, so you can't actually find where it is on that number line. It is an irrational number. Decimals that never end are irrational numbers. So if we looked at the square root of 2, it's not 1, it is 1 point something, and that will continue. It is an irrational number. There are also other forms of irrational number that we don't use. E is one of them. There's this crazy symbol like that. Something like that. And then, wow, it just escapes me. But we are not going to look at these right now. We're really just going to focus on numbers that are not rational, such as non-repeating decimals, square roots that do not have an end. Okay? So now we're going to take all of this information that we learned. This stuff right here is super important, and we're going to include it into a circle map. So turn to page 15 in your book, and we're going to make page 15, we're going to call that rational number, and we're going to call it a circle map. Okay. So our frame of reference is rational numbers. We're going to say rational and irrational numbers. Okay, so inside here we're going to say inside is rational. In here you're going to write everything that's irrational. And out here we're going to write the exceptions. So whatever is irrational will go out here. Okay, so we're gonna write everything that is rational in here and exceptions or irrational numbers on the outside. So if we go back to this note here are at least 6 different examples, right? So we can just include that. So we're going to talk about negative numbers. And so take this time and just go ahead and brainstorm. What else can we put out here? Can you put an example of a negative number? -3. That is a rational number. What else can we put out here? Whole numbers, right? So a whole number would be anything. Let's just say +3. We can say decimals. Here's an example. We can say fractions, right? We can say a ratio. 1 to 2. Let's do 1 to 3. What else can we put out here? Negative numbers, whole numbers, decimals, fractions. Oh, repeating decimals, right? So anything that repeats, any repeating decimal. .3 with a bar over it. What about a perfect square? How about the square root of 16? That would be a rational number. Square root of 16 is 4, right? How about a cubed root? Let's say 8. Okay. Perfect cube and perfect square. Go ahead and push pause and throw some more examples into your inner circle here and see what you come up with. All right. Now, exceptions, there's very few. My irrational numbers are going to go out here. And we want to talk about in terms of pi, which is 3.141, and then it continues indefinitely. What about a square root, let's say a square root of 2? We don't know what the square root of 2 is, so it could possibly be an irrational number because it doesn't end. It's going to be 1 point something, right? And could be a negative square root, negative square root of 11. Do I know the square root of 11? I'd say it's going to be somewhere in between 3 and 4, so it's going to be 3 point something, but I don't know that it's ever going to end, right? That decimal was not going to repeat. So these are all irrational numbers, and these are the only irrational numbers that we will worry about in the 8th grade. Okay, so make sure that you have this circle map drawn into your spiral notebook, and it should be number 15. Make sure you included some good stuff in there. It should have a frame. It should have the outer circle and the inner circle, and this and the inside is our topic, and we're going to use circle maps to create some good stuff. Okay, it's great to help us understand concepts such as rational and irrational numbers. All right, that's it. We're done for today.